Well, ladies and gentlemen, let's start today's first keynote session. Professor Dr. Gwo-Jiun Horng will deliver a presentation on IoT and biomedical. He is from Southern Taiwan University of Science and Technology, Taiwan, and would like to invite Associate Professor Ari Priharta as the moderator. Well, Mr. Ari Priharta, over to you.
Okay, hello.
You can listen my voice. Hello, Gwo-Jiun. How's your Puchen?
How's your
Puchen? Dijen how ma?
Okay, I how.
Đi chơi phân là. Mình chơi how long? Ready?
Ready?
Okay. Hello, the audience. Greeting. Very good morning. My name is Ari Priharta. I will taking care of the sessions for the 40 minutes toward. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah wa syukurillah. La hawla wa la quwwata illa billah. Amma ba'du. And today we have a very nice professor, very young professor from STUST. He is my brother in Taiwan, and we still have a contact until now. We have a lot of research and paper together. I hope today we have a good experience with Gwo-Jiun Horng with his speech related about Internet of Everything. Is it correct, Professor Horng?
Yeah.
Okay. So today you have a 30 minutes for speech.
Okay.
你要30天？那30天啊？ Okay. Okay, I give the time, but before that, we wait the video introductions here about your curriculum vitae. Okay, Professor, I give you time for a speech now, and I will notice you if time is up. Thank you.
Okay. See my slide?
Very clear, very clear.
Okay. Okay, hello, ladies and gentlemen. Good morning. My name is Gwo-Jiun Horng. Thank you for the invitation to the conference and share my research work with you. Today, my topic is infinite probability, AI and IoE. So, and AIoE. Okay, next. About me, I serve the Department of Computer Science and Information and my research interest AIoT, mobile service, and cloud network and smart city and intelligent transportation system. Because I think a lot of things can happen at any time. Technology can come on with human development at any time. So I think everyone is surrounded by infinite probability. Technology can create infinite probability of service. Always come from humanity. Today is focused on IoE. Next, everyone will know if IoE is different from IoT. Then I will introduce IoT first. In fact, many parts of the world have a smart. For example, smart home, smart city, smart health is all around us. Of course, these technologies also generate a lot of information at any time and any location. So let's analyze and predict the probability of the future. The Internet of Things, IoT, mainly include devices and how they connect each other or to people. The connectivity of everything is wider and affects many important components of everyday life. So, IoT is device that connect to each other, but IoE is Internet of Everything, and elements of people and elements of data is an extension of IoT. We can see the picture on the left, which represents a kind of human-to-machine communication. Hand-drawn symbol, word, and the number, and anyone, anything. And the machine can recognize information. In addition, the right diagram is the concept of IoE, people to people, people to people, and machine to machine, or people to machine, in which data will be generated through data module. Some data can be used in business or smart home or smart city or mobile service satellite. So there are 4 modules, includes people, data, things, and process. The things sensing of medical monitoring is placed on the person or inside the body, and the data is transmitted to the machine by wireless communication. Wireless communication includes Wi-Fi or Bluetooth or LoRa or any wireless interface. Data collection, the cloud data and the analysis predict people to people, machine to machine, or people to machine. The generated data is collected through the data module to make decisions and then put the result command into the process. Do the right time to do the right thing. Okay, it's the IOE. So I present two cases to my research work show you. One is novel nasogastric tube with wireless chip. My co-author is Chi-Mei Medical Center, Dr. Jian Qing and Dr. Chen You Ho. Okay. So why do we need to input the this nasogastric tube? NG tube is common procedure in critical setting to provide feeding of or administration of drugs. The NG tube has to be confined to the location of the stomach before feeding. Misplacement of NG tube to the trachea can lead to life-threatening conditions, such as pneumonia after feeding into trachea. Transition method for confirmation of the position of the NG tube are not 100% actually or easy to perform complete by X-ray. Our product tube can repeatedly and conveniently confirm the proper location of the NG tube. It's not 100 in the stomach and the trachea. So we found the UK from 2005 and to 2016, and from the NG had a lot of cases in trachea, and the death toll is also very high. Then you will be sure to ask what kind of method will be used for position the nasogastric tube location. 1. Listen to the bubble sound over the abdomen by stethoscope while air was pushed rapidly via NG tube. 2. Complete by X-ray. It is very expensive. 3. By pH value of content experia from the tube. 4. By ultrasound. It's very many times to use. There are 4 modules. There are 4 modes you can use, but some Asians are more complex and some expensive. That's why we propose an innovative way of wireless and convenient and low cost. So we address critical unmet need, reduce X-ray exposure, easy to perform, and repeat to use, applicable. So RFID, you see this RFID radio frequency identification sensor microchip is mount at the tip of the NG tune here, in here, in here. We designed the passive RFID frequency between 120 kilohertz to 114 kilohertz. Sensing distance of about 10 to 15 cm can detect the signal in vitro. Results. We test the location in the stomach and the trachea can be clear, complete, 100% is me. And this work was also awarded Taiwan's National Innovation Award in Critical Research. And the second case to show my research work. The other one is building an optimal navigation motion map pace for deep learning street view analytics. When we go to unknown location, we usually design the path to move by following the advice of the navigation system. The result is that user may get a route that is not the fastest and the shortest walking distance. The driver's time wastes about 29 hours a year due to factors such as the road path or unclear direction of the satellite navigation system. OpenMap is a shared economy. Although difficult to maintain, everyone can enjoy the convenience of the systems. System architecture. We use image classification technology and route planning algorithm to find shorter and faster walking path, not driving car, walking path for people on the road. Continuous update the Castro map database through the power of the community. From the figure, you can see 3 modules: network, service, server, path planning module, and the image classification module. User navigation request to map new service, and navigation request to path planning module, and the feedback navigation path to user. Developer stream view image upload stream view image, map data management, and the platform, and the GPS route to stream view image at the same time to the image classification module, and pass data to developer. The web server is responsible for verify what request the user sent after image classification has obtained streetscape classification result. The result is sent to the routing module at a new routing consideration. So process image content is divided between static and dynamic street streetscape. Static streetscape is into the NASnet, and the dynamic is video data into the MapNet. We use the two modules to implement the image classification. Use of static image classification recognition NASnet. What are its advantages? The model architecture of neural network is automatically selected through reinforcement learning pattern and reduce the amount of time spent during neural network structure. The accuracy of your model can be quickly verified due to pre-training in small data set, not big data set. Use of dynamic image recognition model using the MapNet. What are its advantages? Traditional map records are based on camera position and visual position at the same time, but there is often loss of focus of camera position and loss of target tracking. MapNet join the position system with environment-aware information such as GPS and indicate to face the problem where camera position was lost in previous model. Estimate the distance the vehicle is moving. Collect travel speed and GPS and so on. For the images, the version seen by machine vision during travel. These data are important parameter when drawing dynamic movement track. When drawing dynamic movement trajectories. Okay, sorry. Next, our overall system need to have a street view image and bearing angle, GPS, latitude, and longitude data at the same time. Collect will steal image from mobile app to collect GPS status and GPS latitude and longitude data at the same time. When using a mobile home app, user need to collect the location point when collecting streetscape image. Map your home camera to define landmark, right and left. Calculate the angle position of the home via system. Collection is complete. You can start uploading street view image to the system. So, image pre-processing. The goal of image classification is to different streetscape image into two catalogs. One is walkable on the road, and there is not walkable. So class 1 photos are workable, and class 2 does not include the workable to class 2. We have 15,492 photos for training, each of which is 720 by 910. And you can see the class 1 photo on workable. These are class 1, and these are class 2. We delete the not workable, and we delete workable the image to class 2. So our motion image use the MapNet model, input data, dynamic street view image, output data, the corresponding movement trajectory in the dynamic streetscape image. After testing, MapNet model can also draw accurate network output result when only studying GPS latitude and longitude coordinate are entered. And actually, the third module, path planning algorithm. We implement two path planning algorithm, A-star and this track, and our proposed algorithm. A-star is heuristic search algorithm. This track is a first Brady algorithm. We propose an algorithm that is based on Brady first and has an algorithm that can reference other ways to save mobile data by queuing. Compare whether there is lower weight to go direct to the original point and move through another node. Due to the liquid after comparison, the algorithm can solve the problem of negative weight drawing. In the fixed plane playground, for example, the traditional path planning is required to bypass the road. If we know that the playground is through, we propose method can recommend user through the playground, not bypass the user. Parameter of training. We can see the parameter table of training. The number of photo for training and the testing ratio is 8 to 2. The class 1 photos ratio 8 to 2. Comparison of classification actually of each image classification model. We can see that the NetNet average actually is 85.93%, which is the best performance of all measures. So we use the MapNet and the NetNet. And the emulation, the path from the university gate. University gate is here to building. Comparison of 3 algorithms, A-star, this trade, and our proposed, with almost very algorithm performs well at the right distance?
You have 3 minutes.
Okay, okay. From the figure, we compare Google Map, A-star, this trade, and our purpose. Then, comparing to 3 algorithms, star, spore, building, star, here, to stone, and not linear distance. So you can see that the method we propose is better than other to has plane. From the figure, we compare Google Map here, Google Map, and A-star, and this trade, and our proposed. Our algorithm distance is small. It's not. Okay, next, actually scenario. Start here. Walk through a walkable environment. Go to here, this one to here, and walk through a walkable environment here, and to endpoint. In the university, and we also apply the OpenStreetMap in Taiwan, in Tainan cities. It's the Tainan station, and the star, and walkable to endpoint. Conclusions. We propose we propose to use the recent popular image classification algorithm, along with route plane algorithm to implement navigation system. 2. The proposed image classification model use NetNet higher actually than other models. Classification has an average actually of 85.93%. 3. Proposal route plane can refer to paths that will not previously included in the database and used at a point of consideration, saving time. 4. In the future, it is possible to automatically mark walkable with satellite images and street view images, and short path recommendation can be achieved through improved path plane algorithm weight. Okay, thank you very much.
Okay, that's a very good presentation from Professor Horng. And the topic is really interesting, especially for me and maybe a part of audience here. 今天我要3拜332人，很多人今天。Okay, maybe I can open the next sessions for this. If you have questions, or before that, I will make a so clear explanation for Professor Horng work related about IoT and IoE. It's a different kind. IoT is only for machine, and IoE is for everything, including people. And the first example is NG tools that use for send the food from mouth to the stomach. And since the audience is more from Indonesia, I will make it clear in bahasa Indonesia also. Jadi proyek pertama itu ada biomedic, ada sebuah pipa yang di dalam ujung pipa itu ditaruh alat komunikasi RFID yang dibuat khusus dan dia bisa mendeteksi perjalanan makanan dari mulut ke perutnya. Yang kedua adalah untuk image processing. Jadi untuk IoE-nya people to a machine, mesin ke mesin, dan ternyata algoritma beliau ini bisa lebih efektif dari Google Map, di mana kita sering kesasar, padahal itu lapangan bisa kita lewati dengan mudah, tetapi kita disuruh muter. Algoritma beliau ini lebih practically. Maybe next time I will invite you to my class to have a guest lecture. Next question, operator can help me who have a question.
Cimbali, excuse me.
Okay, from Professor Muladi. Okay.
Okay, good morning, Professor.
Morning, good morning.
Actually, interesting the second topic, your second topic about the AIoE. Yeah, it's about the mapping. For example, like in Indonesia, for development countries, the environment change frequently. So how often the system should update the video or the picture of the environment? And the second question is how to collect the video or the picture from the device. Is it the user mobile device or a special device to collect the data and send to the server? Because if you use the like 4G or 5G and then we need high speed transmission, so the packet loss is still high, even the latency is low. Okay, thank you.
Okay, before Professor Horng answer the questions, the first questions, maybe I can make it clear. Check the Nikan auto message. Nikan can auto message.
Okay.
Okay. Okay, ma.
Okay.
Okay. Okay, I let you answer the question.
That's the net.
The road short update time.
Update time. Okay.
Oh no.
Okay. I sharing the PowerPoint. Here, the first question.
It's okay. The picture.
The user data, check data type. And yes or no? Yes, image data is statical to NASNet. The no is the dynamic video data, so MapNet. So use through the MapNet and into the NASNet processing.
Excuse me, Miss.
And road network. The road network and NASNet in output is constraint workable path. To the network and workable path to network service module for update map data to in database. Professor, okay?
Yeah, okay, understand.
Okay. Maybe how many? Question 2.
Question
Okay,
2.
okay. 什么东西？什么东西？
使用特
什
人。
么东西？
No special device.
Okay.
Mobile home and mobile home app. We create app to capture that static image and record the video image. Okay.
Okay.
You update feature.
Okay, thank you, Professor.
Okay. Okay. Maybe it's clear for
how many?
No.
Features. Okay. 13,000 features.
Okay. So, okay, terima kasih Pak thank you. Sorry, thank you for Professor Muladi and Professor Horng. Because time is limited, maybe only one people asking here a lot. If you have any questions, you can ask the operator or our I-CoRE committee, where the Professor Horng address, especially for email address, you can ask and typing questions for him later. Now is the sessions for giving a certificate. Okay, it's very nice, and maybe we can take a picture for a while.
Thank you very much.
Already? So I give the last final greeting for us, and thank you for the audience listening. Professor Horng and his work is a really talented professor in the young age. Is my brother's lab in Taiwan. Okay, Professor Horng, thank you very much. See you again later. And don't forget to teach in my class, okay? Just one time. Okay, thank you very much. I give back to the host. Thank you very much. Bye-bye.
Thank you. Bye-bye.
Assalamualaikum warahmatullahi wabarakatuh.
Thank you so much, Professor Gwo-Jiun Horng and Mr. Ari Priharta. It's a very interesting and engaging discussion and presentation.